So for example number 3, we have a similar situation. I have a tangent segment from E to A, and then I have a secant segment from E to C to D, and that relationship would be EA squared is equal to EC times ED. It doesn't look like a C, does it? So, and we could prove this. Just when I do proofs with you guys, I think it overwhelms you. If you're going to go on to college, you're going to have to learn the proofs, like if you want to be a math teacher or a mathematician or an engineer or something. It is available on page 574. You can take a look at it. But mathematically, that's what it is. So remember, what this is the tangent segment squared. So whatever the tangent segment squared is. And then the secant components, right, it's going to be the short part times the long part. So I'm going to draw an example here. So a perfectly drawn circle. Okay. I could do a little better. All right. So this is R. This is Q. And the length of the tangent segment is 16. This is S and this is T. And we're told that this is 8 and that this is X. So now the tangent line is 16, so we're going to say RQ squared is equal to RS times RT. So we have the tangent squared is equal to the short segment times the long segment. So RQ is 16 squared is equal to RS, which is just X, times RT, which is X plus 8. X plus 8. So 16 squared is 256. Then X times X is X squared. And then X times 8 is 8X. So this is going to be some hardcore algebra, not going to lie. So what we're going to do is, one of the things we haven't talked about is the quadratic formula. And so basically what I'm going to do is I'm going to subtract 256 from both sides. And I get 0 is equal to x squared plus 8x minus 256. So the quadratic formula is this: is if you have a quadratic that's set equal to 0, and it looks at this is not the formula, but this is how you solve a quadratic. So this is what we call a quadratic. This right here. If you have something written in this form, a number times x squared plus a number times x plus a number. And it could be plus or minus, so in this case we have negative. You can find the value of x by plugging it into this formula. It would be negative b, okay, plus or minus the square root of b squared minus 4ac all over 2a. So the first thing I need to do is establish what a, b, and c are. So this is 1x squared. So a equals 1, right? Like ax squared, 1x squared. B equals 8, right? So it's like bx, 8x. So b is 8. And then c is equal to negative 256. So plus c to negative 256. Okay. So now I plug this into the formula. So x then is equal to negative b, which is 8, plus or minus the square root of b squared, 8 squared, plus, or no, minus 4 times a, which is just 1, times c, which is negative 256. Okay? All over 2 times 1. So then this becomes x is equal to negative 8 plus or minus the square root of 64, and then 4 times 256 is going to be 250 times 4 is 1,000, and then 1,000 plus 4 times 6, which is 24, so this will be 1,024. Okay, all over 2. And we're going to start to run out of room here in a second. So this adds up to negative 8 plus or minus the square root of 60 plus 20 is 80 plus 4, so this is 1,088 divided by 2. Okay? Now, this is where this is part of the tough part about this. I gotta find my calculator on this. So what I gotta do is I gotta find a number that goes into 1,088. So I gotta think 2 squared equals 4, 3 squared equals 9, and so on and so forth. 4 squared equals 16. And so I think 4 squared goes into this, so let's see. So in other words, the 16 go into 1,088. 1,088 divided by 16 equals 68. So 16 goes into it for sure. It goes into it 68 times. But let's look. I'm curious. I wonder if not 6, 8. I think 8 squared will go into it. So 8 squared equals 64. So let me think about that. So let's try that. 1,088 divided by 64. Yeah, 17 times. So then I could rewrite this as negative 8 plus or minus the square root of 64 times the square root of 17 all over 2. Now the reason I did that is because 64 times 17 is 1,088, but the square root of 64 is just 8. So then I could rewrite this as negative 8 plus 8 times the square root of 17. Now, because they're both being divided by 2, I can divide them separately by 2 like that. All right, that's a property of fractions. So then my final answer, and I'm just going to write this on a separate sheet of paper, my final answer then would be negative 4 plus 4 square root 17, because 8 divided by 2 is 4, 8 divided by 2 is 4, and the square root of 17 remains the same. So this is our final answer for x. Whew. That was a lot. Okay?